Now we're going to figure out what is our vertical intercept. We actually just already found that. We were kind of a little ahead in that last one. So we just did that same work over there. We found n of 0. Ended up coming out to be just what we thought it should be, that initial amount. Okay, so what's the practical meaning? That is the initial number of cell phone users in 2000. In millions. It's cell phone users in millions. So what does the value of A and equation represent? So A is that 109.48, and that is the initial number, and also our vertical intercept. That's what it would be graphically. So now we're coming back to that general form of our equation. Whoops. Okay, so we've already looked at this equation here, just without the A. Okay, we already know about B being growth or decay, and now we know that that A is the initial value. So let's look at this first example. So we've got a function f of x equals 5 times 2 to the x. So that has a y-intercept of 0, 5, right here. Here's our y-intercept. There's our A. This is a growth one. That means you're going to be doubling for each x. Growth factor of 2. Okay, second function, they're just giving us a couple. This right here is our A, and this is our B. So this is a decay factor, but it has nothing to do with A being less than 1. It's just strictly based on B. So using the function, the one we just created before, to estimate the number of cell phones in 2010. So 2010 would mean that our t value is 10. We are 10 years past. So n of 10, if we plug this in, we have to do 1.13 to the 10th power, not times 10, but the 10th power, and then times it by 109.48. So if you do this, this comes out to be 371.64, and that's millions. So then they asked, is that a good estimate? So it depends. We don't know what the cell phone, what the trend is going to be past 2006. According to our table, it only goes through 2006. So it may not be a great model. We're way outside the data. The data ends at t being 6. This is 4 years past that. So it's extrapolation, and it may not be the best amount. Okay, so now we're going to start looking at, this you're going to definitely want to use your table. So you may want to stop the video, or you may already have it in there, but I would put your n of x or n of t, but in the calculator it's going to actually be in terms of x. So you might want to go into y1 and put this in, our function. Put it into y1. You might want to get your windows set. You're going to have, you probably will have to change some windows if you want to view it. And I want you to use the table feature for some of these. This question right here is asking, how many years does it take for the initial amount of cell phone users to double? So the original was 109.48, and they wanted to see how long does it take to double. Okay, so you're going to have to use your table and kind of just look, when does it start to reach about 218 million or 219 million? Okay, and how long is that from the initial? And you'll find, once you kind of play around with your table, it takes about 5.7 years for that to happen. So it takes about that many years for it to double. So the neat thing about this is, it would take for this particular function. Now the next thing you're asking, what if I want to go from 218 and double 218? How long does that take? Okay, if you use your table and just look at your y values and find when can you get closest to about 438 million, you're going to find the same thing. It takes about 5.7 years. So the only way to do that right now is to plug some values in or use the table. The table is the easiest thing right now to just see how many years is it taking to double. Okay, so it's gonna, for this particular function, this is its doubling time, okay? So for NFT, it takes 5.7 years for any of these number of cell phone users to double, whether you're starting at 2000 and seeing when that amount doubles, or seeing if the amount in 2005 doubles, whatever it is. Okay, so it's going to be true for this whole thing. Okay, so how long for anyone for this function takes 5.7 years about. So each function has its own kind of doubling time. So we're going to do that for another one down here, and I do definitely want you to take this function that they're giving us here. This is the balance in dollars of an investment account. Okay, so let's just kind of look at this. I know they already give us everything we want down here, but let's just talk about it. So that 5,500, that's the initial investment that you have. Okay, and we would say that it's increasing 12% each year. Okay, that 1.12, the 1 is just your initial investment, keeping that initial investment. The 0.12 is how much it's growing every single year. Okay, so they want us to determine the value of t when the balance is doubled. So double the initial would be 11,000. So you want to put this into y1, okay, obviously with x's and not t's, and then use your table. And I think they show an example of it in the next slide. Let me take a look.